Okay, everybody, we're going to go through a couple of problems on a worksheet that was assigned on Tuesday. This is your practice problems for stoichiometry, the mole-to-mole, and then we're going to look at the mass-to-mass. We're going to work about 2 problems on this on each side, and so hopefully this will help you get through some of it. One thing I was going to tell you is, I don't know if you've noticed this, none of these equations are balanced. So that's the first thing you're going to want to do is go and balance all of these chemical equations. Once, if you don't remember how to do that, you need to go and look up a tutorial on how to balance equations. And once you figure that out, then you can start your problems. Okay, here we go. Let's look at this one first. Number 1. You have N2 plus H2 yields NH3. That is not balanced. So the quickest way to do that, I'm going to put a 2 there. So that takes care of our nitrogens. So, and then 2 times 3 is 6 hydrogens. So I need to make this be 6. So I'm going to put a 3 right there. And now everything's balanced. One thing that I told the kids today in class was you need to look through this, and as you're reading it, pick out what the known is and what the unknown is. So it says how many moles of hydrogen. So I'm going to go look at this equation, and I'm going to circle the hydrogen. And I'm going to go ahead and label it that I'm looking for moles. Okay, are needed to completely react with 2 moles of nitrogen. Okay, so it says that I have 2 moles of nitrogen. So this one is just plain nitrogen. And it says that I have 2 moles of that. I'm going to go ahead and label that 2 moles. All right. Now that you know that, we can get started. Since this is a mole-to-mole problem, I'm just going to go ahead and set up a mole-to-mole ratio of the 2 things that are involved. And I'm going to say, okay, so in the ratio, for nitrogen to hydrogen, if you're looking for the ratio, the mole ratio, you just look at the coefficients. So I would say this is a 1:3 ratio. For every 1 mole of nitrogen, I have 3 moles of hydrogen that react with it. That's the ratio. For every one of these, I've got to have triple the amount of hydrogen to make it react. I'm going to set this equal to what I'm given now. So this is my new information. I have now 2 moles of nitrogen, so I want to know how much hydrogen, so I'm going to say 2 over X moles of hydrogen, and that's going to let me figure out how many moles of hydrogen I would need in order to make this reaction work. And again, in the original equation, I know it's a 1:3 ratio. So for every one of these, I'm going to have triple the amount of hydrogen moles to make it work. So now if I have 2 moles, I want to know how many moles of hydrogen I'm going to have. All I'm going to do with this information is just cross multiply and solve for X. So I know that 1 times X is equal to 6. And so my final answer is just going to be 6. And you can't just have numbers. In science, we need to have units. So we're going to have 6 moles of hydrogen. That's the value that would go there. Okay, that's the correct ratio. So 6 moles of hydrogen would react with 2 moles of nitrogen. Okay, so let's keep going down. Right here in this reaction, this is potassium chlorate that breaks down to make potassium chloride and oxygen. Okay, and again, we want to make sure it's balanced. It is not right now, so I have 3 of these and 2 of these. So I'm going to go ahead and balance my oxygens first because the K and the Cl are fine. But I'm going to put a 2 here because the least common multiple here is 6 between the oxygens. So now I have 6 oxygens on each side of the equation. But of course, I have 2 Ks and 2 Cls now, so I'm going to fix that by putting a 2. All right? Now the question says how many moles of oxygen. So I'm going to be looking for moles of oxygen, which is this one right here. So I'm looking for that. That's my unknown. Are produced by the decomposition of 6 moles of potassium chlorate. Okay. Now potassium chlorate is actually this one right here. This is known as potassium chloride, but this is my chlorate. And if you're curious about names, all you have to do is like Google it. If this were a quiz or a test, I would give you the formula right out here to the side. Okay. All right, so this is my potassium chlorate. And again, it told us in the equation that we have 6 moles of that. So if we set up just a direct proportion, we're going to use what we know from the formula or from the formula equation, the mole ratio. So the mole ratio, the mole to mole ratio, says this is 2 to 3. So I'm going to go, I have 2 moles of KClO3 for every 3 moles of O2. And then I'm going to set that equal to my new information, to what I know now. Now they're telling me I have 6 moles of potassium chlorate. So I'm going to put that right there. And I want to know if I have 6 moles, well, how much oxygen, how many moles of oxygen would be produced from 6 moles? Okay, so now I have it set up. And again, this is the original, like from the original equation, and this is my new information. So here's from the original equation, this is my new information. So, and again, at this point, I'm just going to cross multiply and solve to find x. So 2 times x, 2x is equal to 6 times 3 is 18. And then I'm going to solve for x by dividing both sides by 2. So x equals 9. And 9 what? 9 moles of O2. Okay? That's how you're going to work these problems for this particular side. I do want to see how you're getting your answers, how you're solving these problems. I did have a couple of people say, well, I can just look at this and I know that it's going from 2 to 6. It would multiply everything by 3. That's fine. You just need to let me know how you know that. Okay? All right.